Cool. So I'd like to start by who am I? Let's get that over with quick because no one really cares. I used Nix first back in 2015 after an IRC friend went on and on and on about how great it was, and I was like, just shut up. I'll try it. And then I got stuck in the NixOS ecosystem since then. I'm working as a DevOps engineer at Twig.io. We do Nix consulting and Haskell consulting and other things like that. I've been a member of the NixOS project, so Nix packages, since 2017, which means I review and commit pull requests at occasions, and the author of a number of to Nix tools, among others, the mentioned in Ili's presentation, which was Vigo to Nix and Poetry to Nix. So let's just first start with these three nice buzzwords that everyone keeps hearing about Nix. So firstly, it's not an imperative language. It's not anything like Python or anything. It has more in common with languages like Haskell and Lisp. It is lazily evaluated. So unlike, which we can quickly demonstrate by firing up Nix repo and say x equals a list of 1, 2, and see that these ellipses things here means that this so-called thunk has not been evaluated. So we really leave that up until something tries to evaluate the x property and walk the list. We only, up until that point, we haven't really calculated what's inside there. And it is functionally pure. So like nothing you do has side effects other than, of course, some things have side effects in terms of files ending up on disk and things like this. But these are strictly controlled side effects controlled in derivations. So let's just have a look of what a typical derivation looks like quickly. At this point, I guess most of you don't really understand what's going on here, except it looks sort of like JSON, but it's really not. And then you have this funky syntax up here, which you probably don't know what it means or anything like that. So let's just build up our knowledge step by step of the language, and then we will revisit this expression in a bit. And hopefully you'll understand a bit more about what's going on. So Nix is an untyped language, so it is dynamically typed in that like functions are not specifying which types they take. We don't have a static type check or anything like that. Though the NixOS module system has types implemented in Nix itself. So it has type checking. I mean, of course, Nix itself has types. They're just not enforced. So let's start by looking at some simple strings. So we have simple, of course, the super trivial strings. We have multi-line strings where like each one here starts with two indents, which means that this indent is removed from the actual string. So if we go back here and look again, we can see that this long description here, it's not very nice that if we have to align things all the way to the left. So we do this so we can write a really nice string where the indentation makes sense. And we also have a special syntax for URLs, but this is, I believe it's already deprecated or on the way to being deprecated.
The RFC is approved.
Okay, so yeah, the RFC is approved. The last syntax there that is deprecated, I just wanted to mention it in case you encounter it, but you shouldn't write expressions with this anymore. Next has paths. And paths is special. They're not exactly like strings. So if you try to coerce one of these paths into a string, that path is hashed and put into the Nix store. And stuff like home directory things are also expanded. Then we have this one I call iPath. I recently just learned why we have this syntax. So this is referencing an environment variable called NixPath, where Nix packages is a property inside this environment variable. And this syntax here, recently just learned was inspired by the C syntax for include. So this is really like the Nix include path. So we have scopes. So because it's a functional language, you can't just randomly, willy-nilly create variables everywhere, all over the place. So you need to create a scope for variables, and this scope is recursive. So if X tries to access Y, that's perfectly fine. We have attribute sets, which are sort of like dictionaries in other languages, but they are, of course, immutable. And here we can see an example of, I forgot to put a rec keyword there. So this won't evaluate, but if we put that rec keyword here, it will evaluate because it's suddenly a recursive attribute set, which means it can reference keys on itself. So a very common idiom in Nix packages, for example, is to set these attributes called pname, version, and then access these attributes in the source URL calculator. So personally, I absolutely hate the rec keyword. I think it should die in a fire, and I will explain a bit more later, but let's skip over for now. Nix, of course, being a functional language, has, surprise, functions. It has really two different kind of functions. One is a regular lambda, the first one. Then we have keyword arguments where you can pass structured sets into a function, and these sets are decomposed and and scoped in the function. So calling a function is just a matter of, well, first we define this function, which takes two arguments, x and y, then multiplies x by y, and so this entire expression encapsulates the function, calculating the value, and then it returns 50. So if we dive a little bit deeper into what we can do with keyword arguments, we can do a few interesting things. I've tried to put them all into one slide, but I think it's complete. So this is your regular, like standard env. It means you always need to pass in stdenv as an argument to this function. libz is another argument to this function, which has a default value null. So you can specify keyword arguments with default functions. And these are also recursive. So you can say standardenv.lib, for example, in... Let's demonstrate that real quick. So this is a fairly common idiom where you have a function that takes packages and lib. But let's make lib dot, and let's say we want to return the concat strings function. So we assign this one to a name in the REPL. We call it. Okay, we need to pass packages. So let's pass packages, and this returns a new function which can concat our strings A and B. So which means that packages is an attribute set which we can infer lib as a default argument from. Then we have this weird syntax which means ignore any unknown arguments. So now I can pass whatever I want to this function, and it will silently ignore any unknowns, while still enforcing that you need to pass, for example, standard env. And then this little funky syntax here, the @args. So the @ is the syntax bit. Args is just an arbitrary identifier for these things, which is all the arguments actually passed to the function. So if we combine this ellipsis with the args, we can extract unknown things conditionally in the function body, for example. And then for completion, I just put another thing there so that we can return. But for now, let's skip that. We have currying, which is really, really, really cool, which means you can take an argument. No, you can take a function, apply a single argument. What you get back is a new function. So in this case, mul5 would return 50 because we have statically said mul5 apply 5 to multiply. And so what you can really think, yeah.
Is it possible to partially apply y without x and redefining multiply?
No. You can really think of this as not just one function, but actually it's two functions. So for each thing, you just go deeper into the function stack. So whenever you see like a 5-argument function, it's not really a single function, it's a set of functions. Huh? Of course you can do that. With a bit of wrapping, you can do exactly what you wanted to do, but you can't do it as a generic kind of. Well, Nix has a number of interesting built-ins. I just grabbed a few as examples, but like any functional language, we have map, we have reduced, but it's not called reduced, it's called foldal. Depends on which language, which functional language family you're coming from, what that's called. We can throw exceptions at runtime saying, like we can't evaluate this on x86-64, for example, these kind of things. We have some serializers and deserializers like to and from JSON. Where we have more deserializers than serializers. And I think that's largely a side effect of JSON being very easy to convert into other things in a derivation, but we can't do it the other way around. So you can't create a derivation that converts something into something that Nix can read and then import that without a number of nasty side effects. So yeah, I already mentioned recursive attribute sets. I just wanted to have them on a separate slide as well. So self-referencing attribute set. Now we have width, which is scoped attribute set. So these two examples here, they are equivalent, where we can say width packages, which means that for the rest of this expression here, the packages attribute set is scoped, so you can access attributes directly on the attribute set. So I prefer the second approach, where you are much more explicit. And a lot of the time, I think what you should be doing when you are reaching for the width keyword is use the inherit keyword instead. So let's say we want to make a list, much like we are doing here. We take an attribute set, we grab some attributes and make a list from it. So much preferable is directly accessing attributes, because it makes code so much more readable. And as someone reviewing pull requests in Nix packages, sometimes with keywords make me go like, okay, what's going on here? Unless function names are completely obvious. Yeah, and also nested with, so with packages, with lib, etc., makes things very, very, very hard to reason about where things are coming from. So personally, I absolutely hate the with keyword. Also should die in a fire, but people keep using it anyway. So inherit is a pretty cool feature, since we work a lot with attribute sets in Nix. We need to be able to grab variables from different attribute sets and scopes and create new attribute sets and scopes. So in this example, we make a set called SumSet and create a new set from that, where we only inherit the Y property. I think this is a really nice thing, especially when you work with multiple scopes and you like inherit SumSet Y, inherit packages, something else. We also have ternaries that looks like this. If true, then yes, else no. We have throws and asserts. And because Nix is a functional lazy language, these throws look a little bit, may look a little bit strange to some people, but it's because, so if true, then throw, like we always have to put things in ternaries because we don't have if statements like a lot of other languages do. We have assert, where we can assert things which will blow up in your face. It can be quite tricky to recover from some assert sometimes, but
I've never seen you can like separate expression with a semicolon.
huh?
Like I never seen you can
Oh,
expression with a semicolon.
that's a special thing for us. So the statement was,
For a sort.
the statement was, I've never seen you can separate expressions with semicolons. And no, you can't, but this is a special case for asserts.
It's on for a sort only.
Yes. So, I mean, you can separate expressions in scopes, for example, with these semicolons, but this kind of thing is not a general thing, it's an assert thing only. And this expression will return the result of x plus y, but assert that 1 equals 1. So a pretty cool feature of attr sets is creating deeply nested attribute sets in a single line. So I think in Tali's presentation you saw a lot of examples where you have these kind of file systems dot something dot some other option, which is actually desugared into this kind of JSON-like deeply nested structure, which I think is pretty cool because it makes these really terse configuration lines expand into some really nicely structured data. You can also access so we don't know if hello is there, so we just say packages.hello or packages.world, which means we try to access hello. If it's not there, we access world. Pretty funky operator in Nix that I haven't seen in any other languages is the // operator, which is not a comment in Nix. It means you take this attr set A equals 1, concatenate it with B equals 2 with the right-hand attribute sets taking precedence. So if both of these things define A, the rightmost one will take precedence over the first one. So this is also, like, because we work so much with attribute sets, we need a lot of nice operators and help to deal with these. We have the regular Boolean operators. Let's just skip ahead. String interpolation, which you saw before. String interpolation for packages is quite interesting, but we will get into that a bit more later on. Yeah?
I see for some strings you use two single quotes to separate them, and here you use triple quotes.
No. Huh? I think this was a mistake. It should be 2 single quotes. Yeah, so my bad. Yeah, so just your list of operators is not very interesting. Let's go on. So now we can get back to this derivation I showed you in the beginning and try to read this. So we now know what have we done up here? We have defined a function that takes the argument standard n and fetch URL. We then, from the attribute set standard n, we take the attribute make derivation, which is a function, and we pass that a recursive attribute set that contains these pname versions, source, do check, which means run tests. And we apply a bunch of metadata of the derivation, and this doesn't actually go into the hash calculation. So metadata of a derivation can change without the derivation needing to be rebuilt. So do we have any questions on this? Like, what's going on here? Is everything perfectly clear so far?
Didn't you hate with?
I hate with. This is grabbed directly from from the GNU hello derivation in Nix packages. Yeah?
It seems like the width is somewhat like a math. Like, if I understand correctly, if we remove the width standard n.lib, it would effectively be that we can attribute set standard n.lib.description standard n.lib.
No. So what we what we have done here with standardm.lib means that we have scoped standardm.lib for this entire expression. And the expression is the attribute set, which means that, for example, licenses is coming from standardm.lib. So if we remove this, we would need to write out standardm.lib.licenses.gpl3.
Platforms.
Yeah, and platforms and maintainers and all of these things that live in standardm.lib.
But only for the right-hand side of the assignments, because the left-hand side is just a name.
Yeah, exactly. Yeah, so that's just an attribute set that gets handled by the standardm make derivation function.
So the function calls,
Mm-hmm.
are they like location-based or name-based? Like when you call a function, is the first attribute always the first argument always the first, or are they based on the names?
No, the first argument, so it was a question about when you call a function, is the argument name-based or location-based? It is location-based. If you want name-based, then you should create a function that takes these attribute sets.
Right.
Can you comment on the indentation with the double single quote marks? Like
Yeah.
the multi-line string, does it get indented or?
It gets the, I don't know what the word is, but dedented or.
Okay.
Yeah, so imagine that all of the white space here is removed. So if you actually, let's look at it in the repo. Meta.long description. So if we use this, yeah. So you can see here it's completely like, yeah. Yeah?
As a reviewer, do you prefer, and there's a function that has multiple parameters, do you tend to prefer the kind of nested lambdas with multiple parameters and then the location-based, or would you prefer, do you think it's wiser to have a single parameter that is an attribute set?
So the question was, is it preferable as a reviewer of Nix packages to see functions taking positional arguments or these attribute set functions? And I would say it depends. It's no one size fits all. They're both there for a reason. Usually, like if your function starts growing in what it accepts, like the standardm make derivation, it's not feasible to have a standardm make derivation that is positional. Yeah. Any other questions so far? So we can look at this NixOS configuration, which I think is pretty interesting because now we're looking at these options again, which gets desugared into this. So what we are looking at here is actually a function that takes config packages and creates this attribute set with deeply nested things, which gets desugared into something looking a lot like this. Obviously too verbose for me to want to write, but that's what happens. And when your NixOS configuration is assembled, like the final thing is calculated, what happens is we take these attr sets and recursively merge them together according to a merge priority algorithm. So basically the options have option weights. So you can say, I want to define this thing, but with a higher weight. So somewhere in your config, you have services.sshd.enable false. Somewhere you have enable true. Which one goes first? Well, in that case, you get a collision saying you have specified this multiple times, but you can also say, apply this with the weight 41, which is higher than the default of, I believe, 10, but I can't remember. Yeah?
When you merge attribute sets with a double slash, is that a shallow attribute set merge, or does it actually do the whole recursion?
So the question is, when you merge an attribute set, is it a shallow one or a deep one? It's with the double slash operator. With the double slash operator, it is only shallow. But what the module system does is like from the inside out. So that's probably more intuitive.
So there's presumably some function in the built-ins that can do that for you?
It's not in the built-in, so that's in the Nix packages NixOS module system. That's not in the language itself, really. A pretty cool feature about Nix is that strings carry context. So when you look at a string, so we take this derivation hello, we coerce it into a string, apply some extra stuff to it, but if we then put this into another string, that will carry a context referencing the derivation hello. So if you, for example, in your systemd service definition, say I want to exec start this Nix store path, how that actually ends up on disk in the correct location that you expect it to be is through the string context propagating through all your strings, and then when your string is realized, it also knows what derivations need to be realized.
And is that because it's lazily evaluated?
No, that's because strings carry a context. So I believe it's built-in has context. Yeah. Hello, whatever. It doesn't have context, but so there is sadly no. So this we can't introspect what the context is from the Nix language itself, but when you coerce something like this, it means that this string carries a direct reference to the hello derivation, which is propagated through when you concatenate strings or interpolate strings. That's always passed through. And if you don't want that behavior, you can use this unsafe discard string contexts, and then you might end up with strings pointing to absolutely nowhere. So yeah, this is what I mentioned it before, but this is why I don't think you should be using with a lot, especially not on the top level. So if we go back to the hello derivation, I think this is mostly fine because it's very narrowly scoped what can be referenced where. But if we move these with statements up there, suddenly there's a whole lot more to reason about. So I mentioned why I don't like the rec keyword. It's because it breaks overrides somewhat. So what do you expect happen if you are trying to override this derivation and set do check false? What do you expect happens with this one if you call the override address function? Well, what will happen is that since this is already do check is only at derivation instantiation time, what will happen is that pybind 11 test, this make flag will be set to on even if we override the do check attribute. So we can desugar this rec attribute set into this. This is what it actually looks like without the syntactic sugar. And we can show even more why this is a bad idea when we start reasoning about evaluator performance. So it's a very common idiom to have a let block up there, and then you do your derivation stuff there. But in this case, we will actually have created a number of scopes. So we will have created 2 scopes where we only need 1. Because if we look at this one again, what actually happens to this rec thing is it gets desugared into something sort of like this. But if we have both a let and a recursive address set, we have now created 2 scopes, which will increase memory in the Nix evaluator. So I would most of the time just say, don't use rec keyword, just use a let block up there, and things are much easier to reason about. So some takeaways from this talk is, I think Nix is a small, simple, and I think very easy language to learn once you wrap your head around that it's not an imperative language. So when I finally realized that this language is essentially a bit of a weird Lisp without the parents, things clicked into place instantly. And learning the language really gives you awesome superpowers to dig into your system and change things at a whim. So you can definitely use NixOS without learning the language, but it will take you so much further if you really learn how to program your system. Thanks. Yeah, questions?
For learning to use the Nix language,
Mm-hmm.
do you recommend just using the REPL, or is there a better way to play with the language?
I think the REPL is the best way.
Okay, and just load files from the REPL.
Yeah. I mean, it can get really difficult to use the REPL if you want to create bigger programs and stuff, but yeah. No, for just learning the language, explore things in the REPL, it will get you really, really far.
Sometimes very smart codes.
Yes. So one person in the audience mentioned this one. So built-in trace is this thing that has a side effect of printing a message and then returning a value. So built-in trace hello will trace hello, and then it will return the second thing, which is world. So yeah, that helps a lot when. Yeah. So another question.
Yeah, even though this is a special purpose language for build configurations and such,
Yeah.
have you found yourself using it for other things?
Yes, like graph problems, I feel like are very nice to express in this language. So yeah, I should repeat the question. The question was, have you used it for other things, even though it's a special purpose language? Yes, I've actually written complex, ish programs, like 1,500 to 2,000 lines of code in Nix, and that's fine. Any other questions? No. Yeah?
Yeah, you said that there is no recursive things or recursive merge, but there is one called recursive update.
Yeah. So I said. So yeah. The statement was I said there is no built-in for. No. Yeah. So for recursive merge of sets, but yeah, there are functions to do so. There is just no built-in operator to do so. Okay. Thank you.